Okay, so here we have a diagram with three position vectors A, B, and C. And P and Q are midpoints of A to B and B to C. So I'd like you to try this first on your own, writing the position vector of O to P and O to Q just using A, B's, and C's. So OP is 08 and half AB. And if I want to go from O to A, well, that's easy because that's just vector A. Plus 1/2. Now to go from A to B, using only A's and B's, if I'm here A and I want to get to B, I can do that by going minus A and then add B. Simplifying this whole expression. And that is one way you can get from O to P. O to Q, if you do it similar way, O to Q is going to be 1/2 of B plus 1/2 of C. So you'd set it up the same way. You'd go from O to B and halfway from B to C, work it out, and you'd get exactly the same thing. So now you can do some crazy things, like if I connect P to Q as a vector, you could go from P to Q using only A, B's, and C's. If you know your ABCs, you're set in life. You can get anywhere. Excellent. Okay. This is why in vectors you're not allowed to just start at P and end at P, because the vector equation for starting at P and ending at P, you go back to O, and then you go back to P again. And that could be P equals poop. Nice. Okay, but if we got P to Q. All right. Yeah, so there we go. If you start at P and want to end at P, you can prove that P equals poop. So we need to go backwards, back to the origin, and then from the origin to Q. And since we figured out what O to P was, P to O will just be the negative. And O to Q and in the end, what's really neat about this, you simplify it all up and you get negative 1/2 A. The B's actually disappear. Negative 1/2 A plus 1/2 C.